So yeah, just reflecting on that project, I wish I had read this book back then. And I wish I had just known that the attitudes my team had embraced weren't necessarily correct, despite all that team being incredibly smart and incredibly hardworking. Hey everyone, welcome to Book Overflow. This is the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our crafts. I am Carter Morgan, and I'm joined here as always by my co-host Nathan Toups. How are you doing, Nathan?
Doing great. Hey everybody.
Nathan, you are not in your usual home state of Colorado this week, are you?
No, I am in Berlin. We've been doing a 2-week trip to Germany. I'm about halfway through.
Very nice. Well, thanks for taking time out of your vacation to record the podcast with us.
Yeah, no, this is fun. This is a fun little break in the day.
Yeah, well, we are excited about the book this week. We wanted to do some quick housekeeping. We just wanted to give a big thanks to everyone coming from Hacker News. We know that our interview with Brian Kernighan, and we learned that after we published the interview, it is not Kernighan, it is Kernighan, did very well on there. We reached the front page. I think we peaked at number 3, which was exciting. Shout out to ZDW for sharing the Kernighan interview and helping get some new subscribers to the podcast. If you're from Hacker News and you like what we're doing, please keep sharing our stuff. And if it goes well, we might give you a personal shout out like we just did for ZDW. And one great thing you could share either in Hacker News or anywhere you're on social media is our Neil Ford interview is live. Neil Ford was kind enough to come onto the podcast and discuss his book, Fundamentals of Software Architecture, with us. That was a great conversation, I thought. Nathan, what did you think?
Yeah, it was great. The fact that we got to talk to both Mark Richards and Neil Ford, hear their perspectives. You could also kind of hear their voice and how it expressed in the book. And they're just a great team. So I think we'll hopefully have both of them on in the future with other books that we have in the queue. So that's pretty exciting.
Yeah, I thought it was fun to see how different they were from each other. But like you said, they're a great team. I think their styles complement each other really well. Definitely check out that interview and definitely check it out if you liked Fundamentals of Software Architecture, enjoyed our discussions on it. And also, if you're on YouTube right now, like the video, leave a comment, subscribe. It helps the podcast. If you're listening via an audio platform, give us a 5-star review. That also helps the podcast. And, make sure to share it with your friends. Share it with your work at the office and your Slack channels. Think how smart you'll seem if you'll say, I was just listening to part 2 in a series of discussions on working effectively with legacy code by Michael Feathers. I mean, that's a really smart sentence right there. We're the Thinking Man's podcast. So we encourage you to share the podcast with your friends. We're excited how quickly we're growing, some of the good success we're seeing, but it's only the beginning, and you could be part of the rocket ship straight to the top. Well, why don't we go ahead and get started with the book? Like we say, we always like to say we read a book a week on this podcast. That's not actually true. We read about 200 pages a week, and then larger books we split up into 2 episodes. So this is part 2 of 2 for Working Effectively with Legacy Code by Michael Feathers. We'll give an author introduction and the Amazon blurb for the book just to get everyone up to speed. So here's our author introduction. Michael Feathers is the founder and director of R7K Research and Conveyance, a company specializing in software and organization design. Prior to forming R7K, Michael was the chief scientist of Optiva and a consultant with Object Mentor International. Over the past 20 years, he has consulted with hundreds of organizations, supporting them with general software design issues, process change, and code revitalization. A frequent presenter at national and international conferences, Michael is also the author of the book Working Effectively with Legacy Code, which is, of course, the book we're reading today. And then the Amazon blurb reads as, is your code easy to change? Can you get nearly instantaneous feedback when you do change it? Do you understand it? If the answer to any of these questions is no, you have legacy code and it is draining time and money away from your development efforts. In this book, Michael Feathers offers start-to-finish strategies for working more effectively with large, untested legacy code bases. This book draws the material Michael created for his renowned Object Mentor seminars, techniques Michael has used in mentoring to help hundreds of developers, technical managers, and testers bring their legacy systems under control. So this is part 2 of 2, but we encourage you to check out part 1 of 2 if you haven't heard that one yet. But don't feel like you got to leave right now with this podcast. Like we say, it's a book club masquerading as a podcast, and the goal we have here is that you don't have to have a comprehensive understanding of the book or have heard every podcast we've done up until this point to understand what we're talking about. This is just going to be a great discussion about some of the ideas we found most interesting in the book. So feel free to stick around because this one's going to be great. And you can always go back and watch part one right after this. Well, Nathan, why don't you give me your general thoughts on the second half of working effectively with legacy code?
Yeah. So we straddled section 2 and then finished through section 3 of this book. And I thought there was a lot of real world wisdom from the trenches that sort of emerged in section 2. We kind of got into this in the first part of this book discussion. I also think there was a lot of nuggets of wisdom in there, but it was a slog to get through. And it's not because of poor writing. It's just because this is both a reference text and a narrative. And so, if you look at actually the titles of the sections, it's like a question that you might have, like, oh, I'm afraid to touch this code. And then there's a very descriptive piece. And unless you're looking specifically to answer that question, reading it through beginning to end is a little bit of a challenge. That isn't a knock to the book. And I think we're going to probably jump into that. It's going to sit on the shelf just like Refactoring from a reference book standpoint, especially if you are someone who's either tasked with dealing with legacy code or you feel that, a job change might bring you into this world. So you might inherit this from the M&A process, right? M&A being mergers and acquisitions. So even if, let's say, you have this cool startup, you guys are doing great, you're growing really quickly, it's entirely possible that your company acquires another one, and that in that process, they maybe either don't assess that the code is exactly where it should be, or they do it strategically, and you might have to take this on. So again, this book is a really interesting reference that's going to sit on your shelf, just like the Refactor book is a reference book that'll sit on your shelf. And I think it's most useful when you're in those kind of times of need. You can pick it up and go from there. And so the third section is that Refactor is how we found out about this book. The Refactor by Martin Fowler book is how we found out about this book. It says, hey, if you have these legacy things, you need to go and check out this book. It's out of scope. But the third section of this book is like, hey, there's this book called Refactor, and I'm going to take a bunch of the examples out of it, but like apply it specifically to legacy code, which I thought was very funny. Like it's just like very funny sort of circular dependency that was there.
Yeah, I agree with what you said about this is ultimately reference material and just the structure of this podcast. We read books cover to cover. Part of that is we view ourselves as kind of guides for you and your reading journey so that we can read all of these different books for you. And we'd love it if you read all of them along with us. But hopefully you're listening to these interviews and these episodes and getting an idea of what ones you might want to read. So in some ways, we kind of bite the bullet for you and just read things quickly cover to cover to give you a good overview of the books and if you think it'd be a good fit for you in your career. This book is not meant to be read cover to cover. I don't think Michael Feathers would ask us to read it cover to cover. And so it's a tough cover to cover read. That's just the shake we give it on the podcast. Make of it what you will, right? I would not, just because the book is hard to read cover to cover, I mean, Wikipedia would be hard to read cover to cover, right? And it's still a fantastic resource. So that's all we'll say about reading it cover to cover. I enjoyed the second half very much. I thought it was much more applicable. I always like when we get to these books where I like when the authors share stories about their careers, where they learn these sort of principles. I always like when we move a little more from the abstract to the concrete. And I thought the second half had a lot of great concrete advice. And something I really took away from this book is that, it's titled Working Effectively with Legacy Code. But I think this is working great for kind of any code base. I think sometimes I think Michael Feathers defines legacy code as like code that doesn't have tests. But I think when we think of legacy code, we think of kind of like big monster spaghetti applications. That's not necessarily the case. Legacy code can also be code that you're just understanding for the first time and maybe doesn't have as many tests as you'd like. But I think, this book has a lot of great tips and tricks for understanding any code base. And I've actually applied some of them in my work this week as I've been reading this book, and they've been super effective, and I'm super excited to talk about them. And I think that's a great segue into kind of our first discussion topic. He has these great chapter titles. Like Nathan was pointing out, like this class is too big, I'm afraid to make changes, or I don't know where to start. Forgive me, I don't know if this is a specific chapter title or just the gist of the chapter title, is I don't understand the code well enough to change it, which I've been here, especially, I started a new job a couple months ago. I've come into lots and lots of different code bases. I know I kind of psych myself out and get anxious about working in a new code base. This was a great section for me. I love kind of the way Michael Feathers puts it. He says, there are other ways of gaining understanding, but many people don't use them because they're so caught up in trying to understand the code in the most immediate way they can. After all, spending time trying to understand something looks and feels suspiciously like not working. We get through the understanding bit very fast, so we can really start to earn our pay. Does that sound silly? It does to me too, but often people act that way. And it's unfortunate because we can do some simple, low-tech things to start work on a more solid footing. So yeah, I want to talk about some of these sort of specific strategies we can use to understand our code base, because again, when I think in the past, when I thought of like, how do I understand this code base? I'm like, okay, I'm going to sit here. I'm going to stare at the code for a really long time, and then I'm going to understand it. And like Michael points out, there are some simple low-tech things we can do to get started. Nathan, what was one of your favorite strategies that he gives in this section of the book?
Yeah. One of them that I highlighted immediately, and again, I agree with you. I ended up highlighting a lot more stuff in the second half. And maybe this was sort of transitioning in section 2, where we start going over these big questions. But it's scratch refactoring, which I thought was such a cool way of thinking about it. Basically, the quote was, forget about writing tests, extract methods, move variables, refactor it whatever way you want to get better understanding of it. Just don't check it in again. Throw that code away. This is called scratch refactoring. And I love this term because I've also called this sort of like kicking the tires, right? Which is this idea of just like change some stuff. See if you understand how the code's actually functioning. And it's a really powerful way to give yourself permission. I think a lot of this section was give yourself permission to like dive in, confuse yourself, do things, because you're going to learn from it. And it's so valuable. Instead of the sort of the analysis paralysis, which I think a lot of us can suffer from. This is this like idea of just no, hop in. Like, who cares? You're not going to commit this code. And I think that was this idea that you're not wasting your time. It doesn't matter if you write a few lines of code and break everything. Well, first of all, you're not going to check it in, right? I like that a lot.
And I think it's great too, because like this is fun. Like it's fun to write code that doesn't need to enter production, that you have the freedom to do whatever you want with it. You don't need to be super careful. It's fun to move things around. And I think ordinarily we would look at this idea of scratch refactoring. I'm going to write code explicitly to throw it away. Seems like a huge waste of time. It's not when you're starting out with a new code base. I'll probably reference this example a couple times this podcast, but at my job, we have some data pipelines, which currently right now are written in Scala and run using Apache Flink. And our task right now is to rewrite those in Kotlin and run them using Google Data Flow. So that's what I'm working on right now. I have one specific pipeline, right, that I need to migrate. And it can be really intimidating understanding how that pipeline works and where the data is coming from and how we're processing it and where it's going to. But this has been really, really fun for me, just doing some scratch refactoring. Like, okay, yeah, let me, I'll change this method, move it here. I think this could look a little more efficient. I'll change it, and now it does this. And I'm doing all of that in the original Scala. It's been great for a couple reasons. One, because I'm not super well versed in Scala, so this is just a great way to play around with it for a bit. But two, it's helped me understand the code base a little more. And when you get caught in that kind of analysis paralysis, and again, for me, I get a little anxious and nervous, right? Like I had to write, and I stuck on my computer on a sticky note. I have breaking something is better than doing nothing, because for me, I just have to get started sometimes. But this kind of lowers that barrier to entry for getting started. Just get in there, code, move things around. For me, I've been surprised at how effective it is in getting a solid start and understanding the code base a little better.
Yeah.
Well,
The next one
oh,
I liked a lot was deleting unused code. And I think that maybe this was a bigger deal when this first was written, because our linters help us a lot with this automatically. But you can still have dead code paths that aren't there. And so in the same idea of like scratch refactoring, it's, hey, can I delete this whole section, and does it break the pipeline? Can I run tests? Can I prove that this is useless code that's sitting here? I think that's a really, again, it's another area where, yeah, do I understand this code well enough to delete something and also make it a little cleaner, right? It's a really sort of powerful idea.
yeah, I totally agree. I think we all love being able to delete big unused chunks of code. You're right that a lot of IDEs take care of that for us these days. This is what Michael Feather said about it. He said, if the code you're looking at is confusing, you can determine that some of it isn't used, delete it. It isn't going or isn't doing anything for you except getting in your way. Sometimes people feel that deleting code is wasteful. After all, someone spent time writing that code. Maybe it can be used in the future. Well, that is what version control systems are for. That code will be in earlier versions. You can always look for it if you ever decide you need it. And I think sometimes we don't appreciate how powerful Git and our version control systems can be. And I don't know. I love that reasoning behind it. Like if any coworker tries to say, like, hey, that code, we might use that later. Say, well, that's what version control is for. Let's, and you could even compromise later. Like I could imagine if you wanted, you could, when you delete the code, you could then submit another PR with a comment where the code used to be that said there used to be a method called this here. It's in this commit if you want to bring it back, right? If you want to play nice with a team member who might be opposed to deleting a lot of code. Well, there was a third method. This is one I've been using at work too for understanding code bases better. And if you don't know where to start, sketching, just like literal sketching, drawing something out. He says, when reading through code gets confusing, it pays to start drawing pictures and making notes. Write down the name of the last important thing that you saw and then write down the name of the next one. If you see a relationship between them, draw a line. These sketches don't have to be full-blown UML diagrams or function call graphs using some special notation, although if things get more confusing, you might want to get more formal and neater to organize your thoughts. Sketching things out often helps us see things in a different way. It's also a great way of maintaining our mental state when we are trying to understand something particularly complex. This is another technique that I'm really loving because so the example he gives is like very high level sketching, and that would be super useful if you have to work with like a big code base and you have to make changes that apply across a bunch of different modules. I've actually been doing a very low level detailed sketching. Like I said, I'm migrating this one pipeline to another. These pipelines aren't very big. There may be 15 files, 20 files, a couple modules interacting with each other. So what I've been doing is I've kind of been reading them line by line and then just making a sketch, right? And so that starts out with, I see, okay, here's the, we declare the class and it extends this class and inherits or implements this interface, right? So I just draw some lines, a downward line for extends, a sideways line for implementing the interface. And then as I'm going through line by line and I'm seeing, okay, now we're going to use this object, then I trace it up to the dependencies and say, okay, so that object right here, that actually comes from company package. But then this one right here, this is from like the Apache Flink package. And so one thing I really like about this is it sounds pretty simple and maybe a little reductive, and I'm almost certain it is, but it doesn't take that long to do. And I find that it's a very purposeful reading line by line of each code. And I've always liked this when I coded. I really like working with my hand on a pen and paper. I used to work for an entertainment company, and we were kind of on the entertainment premises in the office. And so I always like to get up from the day and take a walk around kind of the more public facing parts of the company just to clear my head a little. So I think anything where I can kind of get my eyes off the monitor, get my hands working a little more, that always helps me. And yeah, just I just like it because it's a pretty low effort way to start understanding the code, but it gets you started. And then when you have to actually start making the changes, you have a really solid understanding of what you're working with.
Yeah. A mantra that I bring up a lot is at work is, can we reason about the code, right? And I think these are all tools that help us reason about the code. We've talked a lot across a common theme across these books that we've read so far is encapsulating complexity, right? Removing complexity when possible, but encapsulating it when that's not possible to remove the complexity. And sometimes when you're having to understand the complexity that was introduced by someone else, doing things like drawing a diagram is a great way, right? Because then you can validate whether this is a true representation or not. Was this a useful mental model of the system that I'm trying to build? So yeah, that's sketching is cool. I'm glad that you're using that already.
Yeah, it's I think I just really enjoyed this book, and it's a common theme we've had throughout all of the podcasts. In addition to encapsulating complexity, and this is like a really dumb thing to say because of course you should do this, but like understand the code you're working with, understand it deeply. I think you'd be surprised if you do a kind of an honest audit of yourself and ask, how well do I understand my code base? You probably don't understand it as well as you think, and we've gotten lots of great tips and tricks through all the books we've read on how do you understand a code base better. And some of these ones we talked today, these tips that we've learned from working effectively with legacy code, yeah, I'm really liking, and I feel like I'm becoming a better engineer because I am developing more concrete ways to understand a code base. I saw a great quote by, I think it was Henry Rollins, the musician and the voice of Zahir in Legend of Korra, if you liked. Where he says, I don't have any talent, so I just get up earlier. And I think there's a lot of truth to that as software engineers. Like we'd all love to be that 10x engineer who can just magically divine, he takes one look at the code base and already understands it perfectly, can code 10 times as fast. Like I would love to be that. I am very much not that. But something I can do and I can work towards is develop these concrete patterns that are easy to apply, that give you that kind of that help get you towards that 10x understanding. So, if you pick up working effectively with legacy code, I hope that's something that you take away from it too, is what are some tips and tricks I can use to understand any code base better? And if you read any of the other books we've been reading or will read, I hope you're coming away with that impression too of how can I encapsulate complexity and how can I better understand the code I'm working with. Well, I think that is a great time for a segue. We will be back with more. We're going to have a quick break from one of our sponsors. Stick around. We've got some fun sponsors lately, and we will be right back with more. This episode of Book Overflow is brought to you by Documentation. Are you tired of trying to decode your colleagues' cryptic comments? Sick of code that's as mysterious as a mid-season episode of Lost? Then it's time to embrace documentation. Documentation is the practice of writing down what your code does, how it works, and why you wrote it that way. Whether you're adding new features, fixing bugs, or onboarding new team members, documentation makes everything easier. No more hunting for answers in Slack threads. No more begging old colleagues on LinkedIn for a quick phone call. With good documentation, your code tells its story clearly and proudly. Documentation. At least write a README, okay, guys? And we are back. Thank you so much for tuning in. So there was another chapter in this book that I really liked. The title of it is "We Feel Overwhelmed. It Isn't Going to Get Any Better." I think a lot of us have been there when working with code. You just are trying to ship feature after feature. You're adding one more strand to the big pile of spaghetti. You feel like you feel just like it says, you're overwhelmed. It's not going to get any better. He has some great pieces of advice for how to deal with that. I guess, Nathan, in your career, have you ever felt this?
Oh yeah, we're actively dealing with this with one of our projects. So again, our company went through a M&A process. We acquired several companies, and some of them, when you have legacy code and you have a lot of bugs, one of the really interesting things that happens that wasn't really brought up in this book, where a lot of this pain comes from, and the overwhelmed section I think really touches on it, is you can get to this feeling of hopelessness because you have so much tech debt and you have so many incidents happening that you're constantly interrupted, right? And so what to work on next constantly changes, because if you have broken code, that becomes the new urgent thing. But you probably haven't fixed the other broken code that has to come through. And you're having a hard time reasoning about it. You don't have the test coverage that you should. Try to fix this other problem, but because you don't have the test coverage, it might actually cause a new one, or it actually might break something else that you were sort of in flight working on. And it can make you feel like, oh my gosh, should I just like start a new code base? Should I just refactor this thing from, or not refactor it, but like, should I greenfield this project? Is it even worth it? And he makes a very good counter argument on what you should do. I guess one of the quotes that I thought was really good is the key to thriving in legacy code is finding what motivates you. Although many of us programmers are solitary creatures, there really isn't much that can replace working in a good environment with people you respect, who know how to make fun, how to have fun at work. I've made some of my best friends at work, and to this day, they are the people I talk to when I've learned something new or fun while programming. This really spoke to me. I have friends that I've worked with across my career. Some of them I still talk to daily. We're the rubber duck to each other on all kinds of projects or throwing ideas. It becomes this sort of like hidden counsel that you have, that you've sort of accumulated over time. But I think it's right. You know, one of the things I will say about the team that I'm working with, that we do have a lot of legacy code we're working with, is we really respect each other. And that's so important, right? When you're having to deal with, I'm overwhelmed, or this is a crazy amount of tasks, or everything's going wrong. If you have that support system, it is something you can fall back on and do, can I recalibrate? Can I move forward?
Yeah, my last few months at a job that I didn't particularly like, and I was trying to get out, and I had another coworker who was in the same situation as me. He was trying to get out too. And that bond we formed through that kind of mutual suffering was delightful, and we still talk and are close to this day. And I'm such a people person. I've always been more interested in kind of the intersection of people and technology than pure technology. I have a lot of respect for kind of the pure technologists, right? Like, I wish I was drawn to the siren call of understanding exactly how TCP works. I'm really not. So I've always strived to form close relationships with my teammates. You know, it's funny. I go to a monthly poker night, and this poker night is basically, it's the one guy who puts it on, and then everyone who comes is just kind of like people he's gathered throughout different ways. Like some are old coworkers. I know him because we're neighbors and go to church together. Other people, like, is his brother, things like that. And so it's kind of this motley crew, but it's all people just that he knows. And I've debated doing this for years. I should just pull the trigger and do it. I really want to make like a group chat that is just my motley crew, right? Like kind of all the different coworkers I've really liked throughout my career, and people, my confidants. Like, maybe it'd be weird, I don't know, but I'd love to just like start a group chat and just be like, hey, like, you guys are all a bunch of smart engineers I've known throughout my career. I thought we could all have this group chat, and then we could serve as each other's rubber ducks and bounce ideas off of. I should just pull the trigger and do that.
You should. I think that you and all of the subscribers are going to overwhelmingly give you the feedback that you absolutely need to do this.
If you're in the comments, leave me a comment. If that's something I should do, if I should start that group chat, let me know. Because I think I found that in life, right? That like, I have like a habit of, I have a couple old friends from high school that I try to text like every couple of months, and I'm usually the one texting. They don't text, they text back, but they never initiate. But I just try to tell myself, I'm like, well, if the shoe were on the other foot, I would love if someone from high school texted me. So I would kind of rather err on the side of maybe being a little annoying reaching out than be so anxious that they might not want to hear from me, that I let these relationships wither on the vine. So I should just apply that to my old work relationships too.
I think you have to at least give it a try now. That's my feedback.
Okay, yeah. Well, I will. If someone in the comments comments and encourages me to do it, then I will do it. And especially if you pester me throughout the weeks. Because then I can just tell people, I say, I have a podcast and the subscribers tell me I have to contact you.
Yeah,
So
there you go.
gives me an excuse to contact them and plug the podcast. Ooh, this is good. But it only works if someone comments. So let me know. And kind of speaking with that about that idea of attitude, right? And where I try to have an attitude of like, well, I'd rather contact someone and feel a little silly and embarrassed than accidentally let a relationship wither. He talks about attitude too. He says, sometimes people are dejected because their code base is so large that they and their teammates could work on it for 10 years, but still not have made it more than 10% better. Isn't that a good reason to be dejected? Well, I visited teams with millions of lines of legacy code who looked at each day as a challenge and as a chance to make things better and have fun. I've also seen teams with far better code bases who are dejected. The attitude we bring to the work is important. And I'm such a huge believer in this, again, that our attitude is important, that we have a large degree of control over how we feel and how we approach problems. That doesn't mean that you don't wind up in some situations every now and again that are just objectively discouraging. But we can still muscle through. We can still be happy. There are times in my career where I've done a really good job of this. I'm actually getting moved onto a new team at work where the problem space is objectively less interesting than the old space I've been working at. But there's some really neat opportunities it brings that I'm really, really excited about. And
Yeah.
I'm getting a couple engineers working underneath me on this team. And I know that a few of them are probably going to be a little disappointed moving off that more exciting problem space. But I think the problem space we're about to start is also super interesting, gives us like a good degree of control of what we're doing. And so I'm trying to bring a positive attitude to it. And my goal is to help the engineers underneath me bring a positive attitude to it. I don't know, Nathan, what's your experience in your career with your attitude shaping your day to day?
I think I think what we bring is a huge deal. I will say that the counter argument is sometimes we can be the frog in the boiling water, where we've been we've been in a dysfunctional relationship at work for so long. And the legacy code is really just a symptom of the problem. It's neglect that's happened to process. And if your team is amazing and you do have that safety net, you can bring a good attitude and say, you know what? It's terrible, but I'm going to make things better. Like I'm going to do stuff. But if you're there and you're constantly being thrown under the bus, or you're there and your management isn't doing what they're supposed to, I would say that there actually is a threshold upon which you're saying it's not me, it's you.
Yeah.
So, and I think I've been in those situations too, where you're like, even the code wasn't that bad, but the work environment was so bad that I'm just like,
yes.
I can't be here anymore. And so, if you have a bad work environment and bad legacy code, your feelings of this can't get any better might be actually accurate. It might not be catastrophizing. But if you have a supportive team and you have an interesting challenge ahead of you, I think attitude can actually bring a lot to the table.
I think it all has to do with how much agency you have in the situation, right? Like I was in a company like that where, yeah, I was honestly there for 3 months before I was like, screw this. Because, and the reason I left and got a new job is because it was 2021 and the market was white hot. And I sent out one resume to like a feeler job and they responded and hired me, right? And so, especially like if the market's hot and your skills are in demand, like I would advocate for job hopping, and so long as you don't do it too much that it negatively affects your resume. But I'm like, no, like if you can find something better, go get something better. But there are situations where you can't find something better. The market's a little frostier now, right? So it might take a little longer to find a job if you're trying to leave a toxic workplace. Your wife could be pregnant, or you could be pregnant, and you are struggling. You need to stay on the same health insurance until the baby is born.
Yep.
And that's 4 months later, right? And so there can be times where you can't leave a job. And in that case, if you can't change the management and you can't change the timetable and you can't change your coworkers, one of the very few things you have control over is your attitude. And so you can bring a positive attitude. But certainly, this is not to say that anyone that is feeling dejected, well, if you just choose not to feel that way, right? Because sometimes your circumstances are so bad that like, yeah, you just need to change your circumstances. I've absolutely been there. One final piece of advice he gives about kind of feeling overwhelmed says, if morale is low on your team and it's low because of code quality, here's something that you can try. Pick the ugliest, most obnoxious set of classes in the project and get them under test. When you've tackled the worst problem as a team, you'll feel in control of your situation. I've seen it again and again. Now, we've seen the age breakdown, kind of the demographics of who listen to this podcast. We find that most of our listeners are between the ages of about 28 to 36. We have some who are a little younger. We have no 12-year-olds. I was really hoping there would be like one 12-year-old listening to this podcast and get a jump start on his or her career. But so we've got a couple students. We've got a couple more senior people. Most of our people, I think, fall kind of in that mid-level to senior engineer. Probably a couple staff engineers there too. Anyhow, all that to say, you might be listening to some of this advice, like pick the ugliest, most obnoxious set of classes and get them under test and think, but I can't do that because my work is assigned to me. And, in that case, this isn't super applicable. But if you are senior, if you're a lead and you're listening to this podcast, this is something you could do for your team. If your team is feeling dejected, there are things you can do as a lead to bring that morale up. One of those is right here, is getting that set of classes under test. But there are other things I'm sure you could pick out from this book to kind of help boost morale.
I think you could propose this idea, right? So even if you're not in a position to make it, just if you're in a brainstorming session, if you happen to be in if you happen to be doing a retrospective, which I think is a great time to bring up these, I'd like to start doing X or I'd like to stop doing Y, right? If you, even as a junior dev, come in and say, hey, I heard on this podcast that, maybe we should try picking the ugliest part of our code and just getting test coverage on that. Like, I know that we've been talking about getting test coverage for months and we just haven't done it. Let's just pick one spot. And this has been effective for legacy code bases. Most people, when they hear this idea, I think would actually nod their head and say, yeah, let's give that a try. Or, let's time box it, or, oh yeah, let's go talk. And if so-and-so if you can get them on board, then we can give it a try. It's a great way to have a sort of an egalitarian approach to this, even if you're not in a position of authority. I know that if somebody on my team brought up an idea like this, I would have been so impressed, right? I would have been like, okay, they've got a good head on their shoulders. I'm going to make sure I listen double next time that they've got some cool ideas.
Absolutely. And use this podcast to give yourself credibility. Like I said, listening to this podcast makes you sound smart because you're not going to say, hey, I thought I'd pick an obnoxious set of test classes and get it under harness. You say, I was listening to a discussion on legacy code, working effectively with legacy code. And Michael Feathers recommended this strategy, and I thought we could apply that. And you can talk about the podcast. You say, here's the thing, listeners. You and I know Nathan and I are not that special, that we're just two guys with podcasting microphones who are reading a lot of books. But the people you're telling about the podcast don't know that. And so you can make us sound really fancy and really smart because you can say, yeah, there's this podcast. These guys, they read a tech book a week. One's a staff engineer, the other's a tech lead, and they had this great discussion on working effectively with legacy code by Michael Feathers, and they had this, and Michael Feathers had this piece of advice, and they talked about it for a bit. Think how much credible you sound by sharing that. We know that it's kind of a lie and a joke between the three of us, but to your team members, this sounds very impressive. But I like the larger point of what you're getting at there, Nathan, which is that even you're just assuming more agency there, because even if you don't have the unilateral ability to assign this work out, you can still propose it. And I agree with you, Nathan. If a junior engineer proposed that to me, and even if we didn't have time in that sprint or just business wise, it didn't make sense to tackle that, I would still be impressed by someone. That shows me that someone's really thinking about the problem, thinking about larger team dynamics of like trying to improve morale. I would be listening more closely for their ideas in the future. Well, why don't we move on? We wanted to talk about some of the nuggets we found from this book. We've kind of covered some big picture stuff, some bigger ideas, but this book's just littered with little nuggets of wisdom. So we're going to do kind of a quick grab bag of some of the principles we liked in this. Nathan, what's one of the principles you liked from the book?
Yeah, so one of them was called the open-closed principle, which, again, tied in to some other ideas that we've brought up in the past, but again, it was expressed in a really succinct way, which says that the open-closed principle is a principle that was first articulated by Bertrand Meyer. The idea behind it was that code should be open for extension, but closed for modification. What does this mean? It means that when we have good design, We just don't have to change code much to add new features. This is huge to me because I spend a lot of time working with teams on API contracts. And API contracts fit the open closed principle really well. It's actually really dangerous to change an API signature. You're going to break people's consumption of the API. And the idea being, right, that you can always add features, you can always expand it. But you should be closed to changes to the fundamental structure of it. And I think if you actually really pull that into your mind for code more generally, you actually have a very safe way to do change management, right? Because I can prove that I won't break existing implementations while still being able to add features and improvements over time. If you overlay this with the idea of semantic versioning, which I know semantic versioning is useful in certain cases and I think is overused in others, but folks who use semantic versioning, the real idea here is that a minor version, which is, we have major, minor, and patch. A patch, right, is imperceptible change to the outside world. A minor is specifically this open closed principle. It's this idea that we're open to adding features. You can always add features, but we're closed to making any breaking changes. And then we signal major versions as breaking changes can exist, right? It's a social contract saying, look, I am actually going to make a breaking change, and that's why there's a major version here. But I really liked this idea of doing this with legacy code, which is that, hey, we have this social contract, we have this, contract within the organization. And if we use this framework all the way up and down of how we're writing code changes, we get this really clean way of adding features.
Yeah, I agree. I think this, the open close principle, this is the O in solid code. I think like the whole SOLID. I think I just misspelled solid. Like I said, for the Thinking Man's podcast.
I'm dyslexic, so
No.
sounded great.
Yeah, but I think it's the O there. And yeah, it was great to see this sort of applied in this book to legacy code. I really liked one of the nuggets from the book. He says, programming is the art of doing one thing at a time. I am super guilty of this. I guess I'm guilty of violating this. Something I have to kind of pound in my head over and over again is that there's no such thing as multitasking. That really, when you are multitasking, you're actually, our brains aren't actually multi-threaded, right? And so you actually have one single thread, and it's just context switching between two processes over and over and over again. And if you're familiar with operating systems, if you remember your operating systems class from schools, you'll know that there is overhead with context switching. So I am guilty of this. I like to think myself a good multitasker, so I have to kind of remind myself, there's no such thing as multitasking. And so I want to be better about this. Like it says, just doing one thing at a time, doing that thing well, seeing it through to completion, pivoting to the next thing. Of course, there's always a bit of multitasking you're going to have to do, but I would love to impose too much context switching on myself. And I would like to be better about that.
Yeah. And the reason we have this whole section on nuggets is that these all didn't deserve their own sort of chapter section breakdown like we have with these other pieces, but they're peppered throughout the rest of the text. And I think they made you kind of stop and go, yeah, same thing. I've found when I've spent mindful time and attention doing one thing at a time, I'm happier. My work's better. I have a clearer sense of purpose. And if I run around, as I would always say, I run around with like a chicken with its head cut off, right? Is that you feel really busy, but then you look back and say, what did I actually get done? Right? Like I was, I was doing 5 things, but I was effective doing 2 of them, right? Or 3 of them, due to the context switching. And so
I'm kind of obsessed with that idea of like the difference between actually doing something and feeling busy. I feel like so much of the modern workplace is a lot of like feeling busy. And I know I'm guilty of that. Like I might spend the whole morning, I'm like, well, I checked my emails and I sorted my transaction receipts, or, and then I looked up this document, and like, that's all well and good. And I guess there are worse things you could be doing than that. But at the end of the day, like, we have to contribute code, or we have to drive towards the business objectives, right? And I think it's shocking how much of business no one's actually driving towards the actual business objectives. That's one of the things I find so strange about the conversation about return to office. Full disclosure, I hated working remote when the pandemic happened, and since then I have kind of hopped full on the remote train. We don't have to go into the detail why that is, but it's been particularly good for my career, so that's part of why I like it.
Right.
Anyhow, I remember just being I was shocked going from being in office to being remote. I became keenly aware of, like, oh, I'm not evaluated anymore on, like, whether I can crack a joke and make someone smile or tell a funny story. There's still some of that when you're meeting over Zoom and all that. But for the most part, you're really evaluated by your output. And that was a kind of a big shock to me, because I had always kind of been the guy who could maybe get away with less output by doing that output with a wink and a smile. So yeah, I've become such a big believer in recent years on, like, having concrete output, not just feeling busy, but actually doing something. And like you talked about, doing one thing at a time.
Have you read any Cal Newport books? Have you read
I
any of his
haven't,
stuff?
no.
Okay, we're absolutely going to put these in the backlog. You're going to get a kick out of this. He's a focus and productivity guru who is also a computer science professor. So it seems
That seems like a great fit.
Yeah, Cal Newport's awesome. I've read probably 2 or 3 of his books. He just had a new one come out, so we should look into that. I think this would fit really well with what you're saying, and I think our instincts here, he did a good job of expressing it. So one of the cool things that I also wanted to bring up from the Nuggets section is what I thought was a humorous quote, just because, again, 2004 or 2005 or whatever, when this book came out, he said, "If it's out by the time this book is released, I suspect that someone will soon develop an IDE that allows you to specify a set of tests that will run for every keystroke. It would be an incredible way of closing the feedback loop. It has to happen. It just seems inevitable. There are already IDEs that check syntax on each keystroke and check the color of code when there are errors. Edit triggered testing is the next step." And while I think that running tests on every keystroke is not a great idea, and is the reason we don't see this, being able to run tests on save is quite common if you have a fast local dev pipeline. And our linters and all of the other static analysis tools that are in place. And so I think while maybe to the granularity of a keystroke, this didn't come to fruition, I also think it was interesting that where his head was on, hey, we had these really powerful IDEs and we can do, like, active feedback for all this stuff. I thought that was kind of cool.
We've seen that in a couple books, that idea of kind of closing or getting a tighter feedback loop between writing code and then testing it, right? And that's something I've mentioned on the podcast too, which is that I want to not think of my code and my tests as separate as I currently think of them. And I think part of getting that feedback loop a little tighter is running your tests more often. Because if you only run them twice a day, it's not a huge deal if they take 5 minutes, right? But if you're running them every time you save, and you're saving after every line you write, you're going to be really annoyed if your tests are taking 5 minutes. So yeah, I thought this was neat too. Like I said, we're not quite at every keystroke. Maybe as our computers get more powerful, we'll invest time in that. It's funny to see kind of like, we probably could have done this by now, but I wonder if more time has been spent. Like, to me, the newer advancements in developer tooling is stuff like cloud IDEs, right? And I guess GitHub Copilot, but that's kind of in a different vein. So sorry, Mike, that's what we put our effort into. We didn't get it on every keystroke.
Well, I know I still think, even if the implementation is slightly different, I think the spirit is still there. In the same way that, we still have to mindfully think about our Git commits, right? I mean, I know that there are some projects like SQLite that's like written their own version control system, that has a pretty radical like view on stuff, and you literally, like, everything in your save history is like part of the branching system. But most people I should, maybe I'm projecting. I like Get because I work on some stuff and then I figure out like what's the commit that's going to be there. That's the piece that I like. Either I want to save it for my own branch, or when I'm trying to roll it up for a code review and I flatten it or do whatever things I'm going to do to it, I get to sort of like craft that commit. I feel like there's a mindfulness practice there that's still important in the same way that like automated testing is great. Like if my pipeline's good enough to do it every time I do a save, then that's great. I would love to get that active feedback. Or maybe I just want to run the linter and I'll run the tests when I push. Or the idea that the only limitation now is practicality and not technology. Like you could. I'm almost entirely sure that in VS Code, if you wanted to just completely destroy your IDE, you could have it run tests on every keystroke. Like it's a terrible. You don't want to do that, but you could. It's the technology's there, and so that's not a limitation anymore. It's really just like what's useful.
Yeah, and like I said, I think this is a great way to make you use your tests more. Is if you're making yourself run them more often. So experiment with that, listeners. Oh, another thing, listeners, leave a comment on YouTube or contact us at contact@bookoverflow.io. And actually, I think Spotify is letting you leave comments on podcasts now. So try us there. Nathan pointed out and we have a couple books in the backlog that aren't strictly computer science related, but are more like productivity books or communication books or things like that. We're debating when or if to read those. If that sounds interesting to you, leave a comment. Or if it doesn't sound interesting to you, leave a comment. Obviously, any book we read, we're going to read from a software engineer's perspective and talk about how to use it in our career as software engineers. But we have debated reading, again, some books that aren't strictly software engineering books. Like I mentioned Made to Stick here a couple of times. We've got that in the backlog. A great one, even though it's like 100 years old, is How to Win Friends and Influence People. So let us know if you'd be interested in more general books like that, or if you want to keep it kind of purely technical. We are flexible when it comes to this podcast. We might read them anyhow.
I've also terrified Carter a bit with putting some mathier books in the background. Yeah. So like a book on graph theory and some other information theory. But they're relatively short. They're dense, but they're relatively short. And this again, another one for folks listening in. We've played with this idea, but if you like it, comment and give us feedback. We've talked about if our audience got big enough, should we live stream a backlog grooming, or should we have some sort of interactive stack ranking on books that you'd like to hear next? I think we're looking for ways that you could influence our process. And so we'd love to hear ideas.
Yeah,
absolutely. Or if you have examples from other podcasts of the process that they use that you like a lot, let us know, because we're constantly trying to get it influenced.
Yeah, we've been really happy at how quickly we've grown. I think we broke yesterday 1,300 subscribers on YouTube, and we've got maybe another 600 or so across all of our audio platforms. So for being a month into the podcast, we are absolutely thrilled. But we're still comparatively pretty small, and I believe we're just at the beginning of this podcast. So this is a great time to give us your feedback, because the comments we get now are going to really determine the direction of this podcast. So help us out, folks. Well, I think that about wraps up our discussion on these nuggets of wisdom. We're going to talk a little bit more about the difference between legacy code and Greenfield code after the break, and then we'll wrap up the podcast after that. So quick break, word from our sponsors, and we'll be right back. This episode of Book Overflow is brought to you by Version Control. Are you tired of losing hours of work because you accidentally overwrote your latest changes? Sick of trying to remember what final v2 real final means? Then it's time to embrace Version Control. With Version Control, you can save every change, track every edit, and never lose a line of code again. Need to go back to that brilliant idea you had last Tuesday? No problem. Want to see who broke the build? We've got you covered. Whether you're working solo or collaborating with a team, Version Control keeps everyone on the same page. It's like having a time machine for your code, except you won't need to perform Johnny Be Good at your parents' prom to save yourself from disappearing. So try Version Control today. Side effects of Version Control may include sudden peace of mind, decreased stress levels, and a newfound sense of order in your code base. Version Control is not responsible for sudden urges to rewrite history, excessive branching, or the realization that your colleague's fix actually broke everything. Consult your tech lead before using Version Control. And we are back. Thank you so much for tuning in. Well, like I said, we're going to talk a bit about legacy versus Greenfield projects. I think we all want to work on Greenfield projects, right? But Michael Feathers disagrees. He says the grass isn't really much greener in Greenfield development. And this is kind of the scenario he lays out. He says, Often people who spend time working on legacy systems wish they could work on Greenfield systems. It's fun to build systems from scratch, but frankly, Greenfield systems have their own set of problems. Over and over again, I've seen the following scenario play out. An existing system becomes murky and hard to change over time. People in the organization get frustrated with how long it takes to make changes in it. They move their best people, and sometimes they're troublemakers, onto a new team that is charged with the task of creating the replacement system with a better architecture. In the beginning, everything is fine. They know what the problems were with the old architecture, and they spend some time coming up with a new design. In the meantime, the rest of the developers are working on the old system. The system is in service, so they receive requests for bug fixes and occasionally new features. The business looks soberly at each new feature and decides whether it needs to be in the old system or whether the client can wait for the new system. In many cases, the client can't wait, so the change goes in both. The Greenfield team has to do double duty, trying to replace the system that's constantly changing. As the months go by, it becomes clear that they're not going to be able to replace the old system, the system you're maintaining. The pressure increases. They work days, nights, and weekends. In many cases, the rest of the organization discovers that the work you are doing is critical and that you are attending the investment that everyone will have to rely on in the future. Now, I don't think I have specifically seen this play out in my career, but I've heard horror stories. It's funny because we're reading now web scalability for startup engineers, and something that the author Artur, I'm going to mispronounce this, Edgemont, something like that. He says, avoid rewrites at all costs. And actually a great blog post if you
I
want it.
highlighted that as well. Yes.
Yes. And this is another name I'm going to mispronounce. Author of Pragmatic Engineer, Gurgely Oros. I really need to learn how to say that because he's a fantastic author and I love his newsletter. He used to work at Uber, and they did a whole rewrite of, I believe it was the Uber driver app. And he talks about how that was a huge nightmare. I have heard rewrite horror stories. Haven't particularly experienced them, but we wanted to take a quick. We're going to talk just for a bit about some of the Greenfield projects we've worked on and some of the legacy projects we've worked on, the differences between them, and how we think about them now after having read this book. And this actually comes as a direct result of the call to action I gave last episode. We went on some tangents, and people said they liked the tangents. I got an email that just said, more tangents, please. Nothing in the body. It was just a subject line that said, more tangents, please. And I cannot tell you how confused I was when I got it. I was like, what the freak is this? And then I remember that I asked someone specifically to email me that. So I use the term tangents liberally. Obviously, we're not talking about just about anything. We're still talking about the context of working effectively with legacy code, and we're basing our discussion in the book. But we wanted to branch out from it just a teeny tiny bit and talk about some of our career projects. And again, let us know in the comments. If you like this, great. We want to do more of it. If you don't like it, we're not married to any particular format in this podcast. So we're happy to keep it tight if that's what we're looking for. Nathan, I don't know. Maybe we'll just go back and forth. Do you want to talk about a Greenfield project you've worked on?
Yeah. It hit me right when we were talking about this because I was like, oh no, I don't know if I have any specific examples, but I actually have a doozy. We had a Skunkworks project. It was a fintech, the one and only fintech company I've worked in. We had a Skunkworks project that was transitioning into code we were trying to get ready for production. The only issue was that it was written in MATLAB. And while MATLAB is a great software when you are doing a bunch of machine learning and statistical models on a single machine, it has real issues with going to cloud computing. There's just it's a complete nightmare as far as doing systems management and getting license keys in the right places. And we knew that we needed to move to Python for this, and it was a huge undertaking. We actually had to do a Greenfield project. It was not a. So we actually, it's really funny. We took this exact approach. We did this sort of characterization tests and built an entire test suite to prove that the new code would behave exactly like the old code. Luckily, it was written in ways that we could throw in seed, random number generators and things like this to get deterministic outputs. And it was months and months. And I think it probably lasted for 3 or 4 times as long as we originally estimated that the project would take, which is, every time you do this kind of thing. And there were some real pit of despair moments that happened too. And I think, this is a common piece, which is, oh, this is a great idea. Oh, this is a little harder than we think. Oh my gosh, this is not going to work at all. And then you're like, okay, wait a second. I think we can make this work. And then you're like, this is going to work. Right? You kind of go through all of these pieces. it ended up being fantastic. Like we ended up at the end of it, really understood the code, right? We really understood. We even found some bugs, but we decided to not fix them until we finished the implementation, and then went back and fixed the bugs. So in a lot of ways, this would happened very much like how to deal with the legacy code by the textbook. um, but it was gut wrenching. I mean, it was just we knew we had to do it. It was a blocker for getting into production. It was the only way that we could actually hit our scalability and parallel processing goals that we needed. And yeah, it was a huge undertaking. Huge undertaking. I mean, one person wrote the original MATLAB code, right, or maybe two people, and it took like 6 people to write the reimplementation, in Python. Some super smart folks that were just cranking away at it. So
Yeah, it's that's an interesting example because, like you said, you couldn't just keep using the MATLAB stuff. Like as
yeah,
you want to scale up and bring it to the cloud in production, like you have to move to Python. But I like what you said too. Like it always takes longer than you'd think. The imprecise nature of estimating software is so fascinating to me because this is a $1 trillion business, and you'd think we'd figure it out by now, and we still haven't. And so there's big money in whoever figures out how to estimate it
I,
properly.
I'll
But I
make
don't
a
even think it can be
I'll
done.
make a computer science joke, but I'm pretty sure that estimating timelines is an NP hard problem.
Yeah.
So
Well, I actually, the Greenfield project I was thinking of, it's funny because it actually didn't fall into a ton of the pitfalls here, but I think it was kind of the nature of the Greenfield project. And that's why it was so fun to work on. So, like I said, I used to work for an entertainment company, and this entertainment company used to, probably still do, drop exclusive merch every now and again. And they just drop it on kind of like the main company store website. But this was a huge problem for a couple of reasons. One, because there was a huge problem with scalpers. And so a lot bots would just buy up tons and tons of this merchandise and then sell it for a huge markup after the fact. And so the company didn't like that. That was a poor experience for the customers. The other thing is that because people were so attuned to when these merch drops were happening, it would bring down the entire website whenever it happened. So we actually, I didn't even, my team didn't even work for like the merchandise part of the company, but we just got like almost like internally contracted out to build it. And so it was super fun. But basically what they wanted to do was they wanted to make like a merchandise sweepstakes page. So instead of just going and buying the merchandise that dropped, you would instead select what merchandise you wanted the option to purchase, and then that would kind of go into like a sweepstakes, and then like a day later you get an email letting you know if you knew and that it was eligible and you were eligible to purchase it now, and then you'd be taken to a page where you could actually do the purchase. It was a really fun project for a couple reasons, because one, because they were so worried about it crashing the website, we didn't build any of this new merchandise sweepstakes page as part of the old website. It just kind of like looked like the old website. We even just just ripped the header and the footer from the bottom, and they didn't really work. But it looked like the old website. But it was basically like a static page running in S3, and so it could handle tons and tons of scale. So that was really cool to see, because that was kind of my first exposure to that at the beginning of my career. And then the other thing, the cool thing was, because people were entering for a chance to purchase the merchandise, before we made any decisions about who could purchase the merchandise, we had a ton of data on how those people were behaving. So like we saw that some people were like submitting for that chance to purchase like 1,000 times. And so we just automatically ruled them out, right? And then it was actually neat because we were like shadow banning people. And then and because the website was so small and so static, we didn't care if there was a bot that was sending 100,000 requests to it every second, because it could handle it. And then on the back end, we didn't care too, because that bot, it just got entered in a file of ignore. And so they weren't eligible for any of the purchases. Anyhow, really cool project. Really fun to kind of, it was one of my first exposures in like a business context to like solving a real actual business problem that I could wrap my head around. Previously, that team had done kind of a bunch of core services work. And so I understood that like it was important to write like middleware that handled internal company authentication. But like I said, I've always been more interested in the intersection of people and technology. So to create a solution to that problem that was a problem that I understood and could wrap my head around and explain to other people, I really liked that. is kind of, and I view it as kind of a pivotal moment in my software engineering journey.
That's awesome.
Well, why don't let's flip to the other side. Let's talk about legacy stuff we've worked on. Nathan, is there a particular legacy project that jumped out while you've been reading this?
Yeah, there's one I'm working on actively. I'm doing platform engineering, so I'm helping support how we bridge to the future. So this is improving CI/CD pipelines, improving developer experience, resiliency, and reliability. So platform engineering for the uninitiated is the next site reliability engineering. Or I should say it's not above. It's a complement to the thought that has gone into DevOps and SRE. So DevOps and SRE, right? Site reliability engineering is an entire discipline around how we can make more resilient and more reliable software. And it takes a software engineering approach to doing the DevOps sort of practices. Platform engineering is this idea that can we build self-serve platforms in which engineers are empowered and enabled to do the right thing by default. And we're working with a legacy code base to try to introduce these ideas. And it's been very humbling for me because it's full of those unknown unknowns, right? It's full of these ideas of, I need to actually understand some fundamental process before I can actually make a recommendation on how we improve it. Or maybe we need to talk to our software engineers about some new ideas that maybe exist. Or we can't get certain self-serve patterns because maybe we don't have proper test coverage, or we don't have the proper on-call policies, or some fundamentals that we have to go back and do. And so it's been interesting because I'm not a software engineer on a legacy project, but I am deeply embedded with a team that has a legacy project that needs these sort of new patterns that are in place. So this book has actually helped me a lot, and I hope they'll be able to introduce some of these ideas to our software engineering team to give them hope, right? To give them this ability to say, hey, look, if we start with this approach, maybe we can get to this one of our goals that we have, which I'm excited about.
I love what you're saying about that idea of giving people hope, because that's something I've really taken away from these books too. I said that about Clean Coder that we read a few weeks ago, where I found it aspirational and that it just gives you a vision of what could be. And I think that's really important. I know there's a lot of talk, especially with like underrepresented groups, where sometimes it can really help to see someone like you who succeeded, because it just lets you know, like, hey, it's possible. And I think I compared it to like how people thought running a marathon in under 2 hours is impossible until someone did it, and then all of a sudden a ton of other people did it too. And I found that with these books, where it gives you a vision that like a better world is possible, which is a really dramatic way of putting it. I kind of found that in my legacy project too. I worked at a big cloud provider, and I wasn't like in the weeds at this cloud provider, like working on internal tooling or anything like that. I worked on a frontline product. And it was not only frontline for external customers, but it was used extensively within the cloud provider for a lot of other products too. So it was really cool to be that close to the action, and also really stressful. And we had a big, it wasn't exactly a monolith. Like, I think it like technically was a microservice, because the things it did, domain was relatively restricted, but it did a lot. Like, I'd forgive anyone who called it a monolith. And yeah, like I wish I had read this book while I was working there, because I was way too scared to change anything. And I felt and everyone on the team felt that way. Like, even our team leads, like, we kind of had like this feeling of like, don't touch it if you don't have to, because our number one, the thing that keeps us as a business is like reliability and uptime. So we're going to be really cautious about this. And I think, yeah, one of the things working at that particular company was, because it was the brand was kind of respected in the industry, and because the people who worked there were really smart, there was a bit of my tendency to be like, well, I don't know better than these folks. And so if they're scared to change it, I should be scared to change it. But again, that's what I love about reading these books. To go on a tangent, I actually had this trouble like 10 years ago. I used to be a missionary for my church, which is like a 2-year deal. And usually when you're as missionaries, you get assigned to one location, you stay there the whole time. Me, I was assigned to Brazil in Sao Paulo. Um, but my visa took so long because it was the World Cup that I spent the first year in California, which is a very weird situation to have. Anyhow, so I left the one location in California and I went to the other location in Brazil. And the way they did things in Brazil was like way different than the way we had done them in California. And in particular, there were some attitudes that I thought were a little like toxic or harmful. And it was really, really tough. But one thing that made it easy is that the kind of missionary handbook was standardized throughout everything, throughout every mission in the world. And I really, really liked that handbook. I thought its philosophies were really good. I thought it was kind. I thought it was a good ethical way to approach missionary work. And so every time I ran into some of those toxic attitudes, I could always fall back on that handbook and be like, but this is what the handbook says. And I feel confident in this. And it worked in California. And we know we're supposed to use it here still. So like I always had that kind of higher authority to appeal to and say, like, you're telling me to do this thing, but this handbook says to do it differently. And so I feel confident in standing my ground here. I feel that way about the books we've been reading here, where going back to that cloud provider, right? I felt scared to touch the code. Everyone else felt scared to touch the code. And I thought, well, if everyone else feels scared, I'm not smarter than everyone else. So maybe we should just be scared to touch the code. If I'd read this book, Working Effectively with Legacy Code, I would know, no, that's not the case. It doesn't have to be that way. Here's someone, Michael Feathers, who's smarter than everyone on my team that I was working with, I would think, right? Who makes a great argument for why you should feel confident in working with legacy code. And if you don't feel confident working with it, that's not the natural state of things. You should restructure the code in a way where you do feel confident working with it. So yeah, just reflecting on that project, I wish I had read this book back then. And I wish I had just known that the attitudes my team had embraced weren't necessarily correct, despite all that team being incredibly smart and incredibly hardworking.
So this is a perfect segue into what are you going to do differently in your career as a result of this book?
Absolutely, right. I talk about some of the higher level things about just not being afraid to work with legacy code, understanding the code. I think I've touched on all those throughout the podcast. Specifically, I've started doing those things, which I mentioned at the beginning, scratch refactoring and sketching out the code. It's been really helpful as I've been migrating this Apache Flink pipeline this week. I want to keep doing that because I just feel like that's, again, it's great to have these attitudes about like not being scared to work with the code. It's also great to have concrete ways to embrace those attitudes. And I just feel like scratch refactoring and making sketches are super easy and a great way to get your hands dirty with the code base and to start gaining understanding quickly. And I feel like that's something that I can apply to every project from here on out. So that's what I'm going to start doing.
That's awesome.
What about you, Nathan?
Yeah. I'm going to play the if morale is low game. So that was the one where you work with a particular team on some legacy code and pick that one section of the code and let's get test coverage for it. Right. And work through that piece. I love that pattern. I think it's a really wonderful way for me to engage with this team and prove out some of these ideas so that we can start making improvements to this legacy code together. So that's where I'm planning on doing.
Well, there we go. I think it's a great place to start. Well, we always like to sign off the podcast too by saying, who would you recommend this book to? Nathan, who would you recommend Working Effectively with Legacy Code? Now that we have fully finished it and comprehensively recommend something.
You know, it's kind of, I like the two-parters because you're like, do I still have the same recommendation that I had at the end of part one? And I think the answer is yes. So the idea was I wouldn't recommend this book for most folks if it's just a random recommendation of, oh, here's the 5 software engineering books you need to read. I absolutely think, though, if my ears perk up and I hear somebody's challenged with working with legacy code bases, especially if they're fans of the TDD methodology, this is a no-brainer, right? And I think maybe I would be a little bit more aggressive about recommending this book after finishing it. So I think I was a little apprehensive of like, who does this go to? But I think legacy code's all around us, and there's a place for this book.
Absolutely. Again, if you're just in the thick of it with legacy code, like this book is for you. I think I would still, yeah, you'd have to be really, really in the thick of it for me to recommend reading this book over Refactoring. I think we're like 99% of people you should read Refactoring. And I don't think Michael Feathers would disagree with that assessment. Refactoring is more general purpose than this book. But yeah, like if you're feeling demoralized about your legacy code base, like this is a great book to read, right? And it doesn't take too long to read it. Like Nathan and I read it in 2 weeks. And you know, a 2-week investment to really change your attitude about your legacy code base and feel more optimistic about the future and tackling it. That's a great investment right there. And in particular, like we've talked about, there's a couple great chapters about what to do if you're having trouble getting started. I struggle with that a lot. I imagine I'm not alone. And so, like we said, this is mostly reference material. And so I'd recommend a cover to cover read for anyone kind of really demoralized and struggling with legacy code base. But if you want to buy this book and use it as reference material, it really should be used for, and not read it cover to cover like a maniac, like Nathan and I did, then yeah, like absolutely check out some of those middle chapters about like what to do if you're having trouble getting started, because that doesn't just apply to legacy code. That's everywhere. And I found that super, super helpful. And yeah, I'm excited about already applying some of those strategies and continue to apply them in my career. Well, I think that about wraps up working effectively with legacy code. One thing I really like about this podcast is I think we feel fondly about the books after reading them and discussing them. A book would have to be really bad for us to not feel fondly afterwards. Like we said, this book, because it's reference material, can be a little challenging to get through. And Nathan and I were texting each other throughout the week and being like, ugh, this one's not exactly a page turner, is it? But it's always great after reading it and discussing it and pulling out our favorite parts. Like, I don't know, I feel fondly towards this book. I'm gonna remember it with a smile on my face. So
yeah, same.
We appreciate you coming along for the ride. So hopefully you've enjoyed this podcast. Like we say, you can always leave feedback, right? If you're on YouTube, leave a comment, like the video, subscribe if you're not already subscribed. If you're listening on an audio player, follow us there too. Again, if you're on Spotify, I think they're leaving comments now. You can find us on Twitter at Book Overflow Pod. You can find us on YouTube at Book Overflow Pod. You can email us at contact@bookoverflow.io. We love hearing from our listeners. And you can also find Nathan on his less regular podcast, but still regular, Functionally Imperative, where he interviews fascinating creatives. I always enjoy listening to that. I need to... my wife has just introduced me to the joy of listening to podcasts at 2x speed. And I found that I can now double my podcast intake by doing that.
That's bold. Yeah, I'm like a 1.5er. That's what
I'm a 1xer, and I really love the Conan O'Brien podcast. My wife will sometimes listen on 2x speed. I'm like, you're ruining the comedic timing.
Yeah,
this
you
man
can't
is a
do
national
that at
icon.
2X. Yeah.
No, you can't put Conan on 2x. The guy already talks fast. Anyhow, well, please keep tuning in. We're really excited about what we have to come next. Check out that Neil Ford interview. We loved it. And stay tuned because we have more great books to come and more interviews with authors. We won't say exactly who yet, but we can promise that we have some recorded, ready to release, and we have some scheduled working through the pipeline. We are very excited to share that with you, and we're so excited that you've joined us here on our journey to become better software engineers, but I hope more importantly, your journey to become a better software engineer. All right, that's it for this episode. Signing off. Thanks, folks.